Hi, boys and girls. Today we're going to be learning about Lesson 2.2 roots. The vocabulary that we're going to be talking about: cube root, inverse operations, perfect cube, perfect square, principal square root, radical sign, and square root. And I just picked out a little meme here. I thought it would be kind of fun. I love chihuahuas. I used to have 2 chihuahuas. I lost one of my chihuahuas during the quarantine. He died of heart failure. But I still have my little girl chihuahua. Okay, so on page 79 of your workbook, square root of a number is one of its 2 equal factors. Basically, and you know, this is a lot of math lingo here. It says the square root of 25 is 5 because 5 times 5 equals 25. So the square root of a number, the square root of, say, 49 would be 7 because 7 times 7 equals 49. All right, these are considered some of the perfect squares here. The square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 equals 9. And the square root of 16 is 4 because 4 times 4 is 16. So we need to fill out the rest of the chart here. What number times itself? Come on, pen, why are you not working? Okay, disregard that. What number times itself is 25? 5. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. And 8 times 8 is 64. Next page. Still on page, this is on page 80. Every positive number has both a positive and a negative square root. Since 3 times 3 is 9, 3 is the square root of 9. But since negative 3 times negative 3 is also 9, negative 3 is also a square root of 9. So 9 has 2 square roots, 3 and negative 3. In most real-world situations, we only care about the positive one. We don't really pay any attention to the negative one. But sometimes they will ask you to identify both. All right? So if they just ask you to find the square root of a number, you just assume they want the positive one. This indicates that they want the opposite of the square root of 25. Well, the square root of 25 is 5, and the opposite of that is negative 5. Here, this means I want both square roots. So the answer would be positive or negative 5. Okay, that sign there is a plus sign and a minus sign together. That's what that is. Okay. So, in order to simplify, we need to find the square root. This says find the square root of 64. What number times itself equals 64? They want you to go through this whole long process of finding factors. Okay, well, 2 is a factor of 64. 4 is a factor of 64. But what you end up with is 8 times 8 is 64. Okay? So the positive square root of 64 is 8. Here, now they're giving you a little bit bigger number. I whipped out the handy-dandy Active Inspire calculator. It does have a square root button. This little squirt button is the square root button. Most of the calculators that you have access to will also have a square root button. It gets a little iffier when we have cube root problems. To find the square root of 25 on this little guy, and you can experiment with these calculators. If you're not sure what order to push these numbers in, pick one you know. I know the square root of 9 is 3. So I could go square root 9 equals, and know that that's not working because it should have said 3. So I need to do it in a different order. Let's do 9 first and then square root, and it gave me the right answer. So now I know for this calculator, I should put the number in first and then hit the square root button. So let's do this problem down here, 225. Put the number in first and hit the square root button. So the square root of 225 is 15. Did it ask me for both the positive and the negative one? No, it just asked me to find the square root. It'll be specific if it wants both. All right, now here they're getting specific. See, here they want to know the positive and the negative square root of 1.21. And they've got this really complicated way of you figuring out how to do that. Don't waste your time. Come over here and type in 121 and hit square root and use your calculator. That's what you have it for. So the answer to this is plus or minus 11. And what that means is positive 11 times positive 11 is 121, and negative 11 times negative 11 is 121. Yeah, this is way too much work. Here we have a couple of checks down here. This one is on page 81. This one's on page 82. The square root of 1.44 is, what'd I do? I hit the wrong button. 1.44 square root is 1.2. So it's positive or negative 1.2. Now this one's a little bit interesting. When you have a fraction like this, you can do this way. You can do the square root of 49 over the square root of 64. And notice that it has a negative sign out here. So it wants the opposite. All right. Well, the square root of 49, I know off the top of my head, is 7. And the square root of 64 is 8. And so the answer is negative 7/8. Okay. Well, we haven't gotten to the fun part yet. The fun part's coming. Now, here is a math no-no. All right, this is kind of like the square root version of dividing by 0. This says, find the square root of negative 16. But we're looking for a number that when multiplied with itself gives us negative 16. But we can't answer this question because there is no number times itself that's going to equal negative 16. Negative 4 times negative 4 is positive 16. So we can't use negative 4. So there is no rational number square root of negative 16 because no number times itself is equal to negative 16. So the square root of negative 16 cannot be simplified and has no rational number solution. They frequently will call this an imaginary number. Okay. Simplified square root of negative 81 using rational numbers. If the expression cannot be simplified, explain why. And you would just say no number times itself equals negative 81. You probably don't want to sit here and watch me write this all out. No number times itself equals negative 81. Okay. No solution. Now they want to show you how to use square roots to solve equations, all right? You can solve equations by using inverse operations. Inverse operations are operations that undo each other. Squaring and square rooting are inverse operations. They reverse each other, okay? If you square a number, 9 to the second power is 81 because it's 9 times 9. The square root of 81 is 9 because 9 times 9 is 81. To solve an equation in the form of x to the second power equals p for x, undo the operations of squaring x by taking the square root of each side. So if you had it, and I hate that they use all letters in here, this would make so much more sense to you if it had numbers. Let me redo the example with numbers instead. Let's say we have that x squared is equal to 16. Okay, then what we can do is we can say the square root of x and the square root of 16. Remember, our rules for solving equations are you have to do to one side what you do to the other. So this was fair and legit because we squared both sides. Well, the square root of a square number is the number. Those undo each other. Squaring and square rooting undo. And the square root of 16 is plus or minus 4. So that's kind of what this explains, only in a really complicated way because it uses a lot of variables. I don't know why I don't use those. So here we have a real number example. T squared equals 169. So you take the square root of both sides. We need to know what the square root of 169 is. 169 square root. And the square root of 169 is 13. So T is either positive 13 or negative 13. So positive 13 and negative 13, right? Here we have another one. We have y squared equals 256. So the way we solve this is we take the square root of y and we take the square root of 256. Square root of y squared is y, and the square root of 256 is 256 square root 16. And if they want both, you could say plus or minus 16. Okay, now cube root. Now this little guy over here cannot do a cube root. This only does square root. So I'm going to have to go to an official calculator, the green one. Are you surprised? All right, so the cube root of a number is a number times itself equals that number. So when we're talking like the cube root of 8, the cube root, and this is how we write it, we put a little 3 here. The cube root of 8 is 2, because 2 times 2 times 2 is 8. No, it's not 6. Everybody always thinks it's 6. 2 times 2 is 4, and then 4 times 2 is 8. Okay? So this is what this is all saying here, is that a number times itself is a cube root. Now, here's the thing. Can you have a negative answer? Heck yes, you can. If you had negative 2 times negative 2 times negative 2, wouldn't that be negative 8? It would. So, can I have a cube root of a negative number? Yes, I can, because 3 negatives multiplied together would give me a negative solution. So, when I tell you there can't be a negative number under here, that's only for squaring, okay? Not for cubing. All right, so every integer has exactly 1 cube root. Complete the table that demonstrates this concept. The cube root of a positive number is a positive number, because positive times positive times positive. So this would be positive 3, okay? The cube root of 125, I think, is 5. Yeah, is 5. Okay. The cube root of 0 is 0, because 0 times 0 times 0. And the cube root of a negative number, negative 27, the cube root of this is negative 3. This can't be positive 3, because 3 positives would give us a positive 27, not the negative 27 we have. And the same thing here, this is going to be a negative 5 and not a positive 5, because this has to end up negative. We're almost to the fun stuff. A perfect cube, you remember we talked about perfect squares earlier. Perfect cubes are numbers that are, an integer times itself will equal them. So 27 is a perfect cube because 3 times 3 times 3 is 27. Negative 27 is also a perfect cube because negative 3 times negative 3 times negative 3 is negative 27. 64, well, I almost said 8. That would be squared. What's the cube root of 64? I've got a calculator. You think I'd know this. I should know this. I had to pause that. I forgot how to put a cube root in the calculator. It's been a long summer. All right, so the cube root of 64 is 4. All right, and the perfect cube, the cube root of negative 64 is negative 4. You would think I should have guessed that, right? Because these were going in order. No, I complicated it. All right. So cube roots of positive numbers. The cube root of 125. All right. Well, I already said 5 is the cube root of 125 because 5 times 5 times 5 is 125. So we have 5. So now they want the cube root of 216. And now I remember how to put the cube root in the calculator. These TI-30s, you have to hit 3 first. Then you go second and the x squared, or the up button. And then you put in the 216. When you guys are back in the classroom, I'll demonstrate that better for you. And then you get 6. So the cube root of 216 is 6. Okay. All right. Okay. The cube root of negative 27 is negative 3. Because negative 3 times negative 3 times negative 3 is negative 27. So the cube root of negative 1,000 would be 10, because negative 10 times negative 10 times negative 10 is negative 1,000. So this is equal to negative 10. Okay. You can use cube roots to solve equations just like you can square roots, okay? You just take the cube root of both sides. So here they're showing you they've got s to the third is equal to, and the equal signs are missing, s to the third is equal to 125 over 8. Then you take the cube root of both sides, and then you get that s is equal to 5/2 or 2.5. Then they tell you can check the solution by taking the 2.5 and cubing it and seeing if it goes back to 125 over 8. And of course it does. A box that is shaped like a cube has a volume of 512 over 27 cubic inches. Could they make that any more complicated? Solve s to the third equals 512 over 27 to find the length s of one side of the box. So what you would do is you would take the cube root of s to the third, which is just going to give us s. But we also need to take a cube root of this side of the equation also. And we can do that by getting the cube root of each of these numbers. Now, the cube root of 27 is 3. But the cube root of 512, I'm going to need the calculator. Hit a 3-second up button, and the number was 512. And that is 8. So we could write that 8/3. That's perfectly fine. Or we can go to 2 and 2/3. Doesn't matter. All right. Now we're to the fun part. Oh, I love these problems. A bulletin board consists of 4 equal-sized cork squares arranged in a row to form a rectangle. If the total area of all 4 cork squares is 36 square feet, what's the length of feet of the bulletin board? Okay. So they're telling you that the area of this whole bulletin board is 36 square feet. Okay? But they want to know what is the length of the bulletin board. In order for us to find the length of the bulletin board, we need to be able to find the length of these squares. Okay? Well, we know that the area of all 4 put together is 36. So the first thing we have to do is divide 36 by 4 to find out what the area of each of these is. Well, 36 divided by 4 is 9. So the area of each of these squares is 9. Well, how long would the side lengths be then if side times side is 9? And you know they're squares. They told you they were squares. So that means that this and this are the same number. Or in other words, we could call them x, okay? And we know that x squared is equal to 9. So then we can take the square root of both sides, and we find that x is equal to 3. Now, we're not going to mess with -3 here because there's no such thing as negative distance or negative length. But what we have learned is each of these squares is a 3 by 3. This is a 3 by 3, and this is a 3 by 3. But what was the question asking us for? It wants to know what is the length in feet of the bulletin board. It wants to know the whole length of this side. Well, how much is 4 3s? 12 feet. Isn't that fun? I love these problems. Like little math mysteries. It's good times. And here's another one. A set of windows consists of 3 equal-sized squares arranged in a row to form a rectangle. So I'm going to draw a picture. I need a visual of this. So I have 3 square windows that are all in a row to make a rectangular window. Okay? If the total area of all 3 windows is 108 square feet, what is the length in feet of the windows? Well, we need to divide this by 3 to find out what the area of each square is. Calculate. 108 divided by 3 is 36. So each of these has an area of 36. Okay? So if these are perfect squares, though, how long must the sides be? Well, this would be x times x is 36, or x squared equals 36. Take the square root of both sides, and we find that x is 6. So that tells us that these squares have side lengths of 6. So getting back to the question now, what do we need to know? What is the length in feet of the windows? And it says windows with an S, so they mean all of them. What's 6 plus 6 plus 6? 18 feet. Oh yeah, good times. We're going to get to do more of those in class, and we have more of those for examples. And this is your video question for this video. The question will ask you, what store does Kermit miss? And you will answer that Kermit is missing Target. Okay? So you get your points for the video. All right, and that brings us to the practice portion. And of course, we do these little babies in class. So I hope that I will see you soon, and we will do these in person or on Zoom. and we will have a good time. And with math, it's always a good time. So that's it for this video. I'll see you next time.